Imagine running a vast empire, one of the largest in history, stretching thousands of miles along the Andes Mountains. Now, imagine doing it without a single letter of written script. How would you count your people, track your resources, or send messages across enormous distances? The Inca had an ingenious solution, and it looked like this: a complex arrangement of knotted cords called a khipu. For centuries, we viewed history through the lens of alphabetic writing, often dismissing cultures that didn't have it as somehow less advanced. But the khipu forces us to challenge that assumption. This wasn't just a simple memory aid. It was a sophisticated, three-dimensional system for recording and transmitting vast amounts of data. It was, in essence, the Inca's hard drive. So, how did this fiber-based computer actually work? Let's break down its architecture. The foundation of a khipu is a main, thick cord. From this, thinner pendant cords hang down. The real magic happens in the knots tied on these pendant cords. The Inca used a base 10, or decimal, system, just like we do today. The position of a knot cluster on a cord determined its value. Knots at the bottom represented the ones place, the next group up was the tens, then the hundreds, and so on. A single figure 8 knot could represent the number 1, while long knots with multiple turns could represent numbers 2 through 9. A space with no knot represented 0. This positional system allowed them to record incredibly large numbers with stunning accuracy. But the khipu's genius didn't stop at just counting. It was a multivariable encoding system. Think of it like a spreadsheet, but made of wool and cotton. The very construction of each cord held meaning. Was it spun clockwise, which we call an S-twist, or counterclockwise, a Z-twist? This simple binary choice could signify different categories of information, maybe distinguishing between military and civilian expenses, or men and women in a census. The color of the cords was another layer of data. White might have represented silver or peace, yellow for gold or corn, red for warriors or war. Some khipus even feature cords made of different materials, like llama wool versus cotton, adding yet another dimension to the data being recorded. You could have a brown, S-twisted, llama wool cord with knots indicating a specific quantity, and every single one of those attributes contributed to the overall meaning. It was a physical manifestation of complex, categorized data. This system was the central nervous system of the Inca Empire, known as the Tawantinsuyu. To manage their vast domain, the Inca built an incredible network of roads called the Capacnan, stretching over 25,000 miles. Along these roads, elite relay runners called chasquis would sprint, carrying messages and, of course, khipus. A chasqui would run a segment of the road to a relay station, a tambo, where another runner would be waiting to take the khipu and continue the journey. This system was so efficient that a message could travel over 150 miles in a single day. So, what information were they carrying? Everything. Khipus were used for the census, tracking births, deaths, and the movement of people. They managed the MITA, the Mandatory Public Service System, recording who had fulfilled their labor obligations for building roads, terraces, or storehouses. They were crucial for inventory management in the Qullqas, the state storehouses filled with food, textiles, and other goods, ensuring that resources could be redistributed from areas of surplus to areas of need, preventing famine. The khipu wasn't just a record, it was a dynamic tool for state administration, allowing for precise, data-driven governance on a scale that is hard to comprehend even today. The officials who could create and read these complex devices, the quipucamayocs, were highly respected accountants and historians of the empire. This incredibly efficient system, however, faced a cataclysm with the arrival of the Spanish conquistadors in the 16th century. The Spanish, unable to comprehend this non-alphabetic form of record-keeping, viewed the khipus with deep suspicion. To them, these knotted cords were tools of pagan idolatry and a symbol of Inca power that needed to be eradicated. In their effort to impose their own culture, religion, and administrative systems, they ordered the burning of khipus. Countless records, histories, genealogies, poems, and centuries of administrative data were turned to ash. It was a cultural catastrophe, a burning of a library unlike any other in history. Our understanding of the Inca world was forever impoverished by this act. But not all was lost. Miraculously, around 1,000 khipus have survived to this day, preserved in museums and private collections around the world. We also have invaluable accounts from early colonial chroniclers. One of the most important is Felipe Guaman Poma de Ayala, an indigenous nobleman who, in his 1,000-page letter to the King of Spain, included detailed illustrations of Inca life. Several of his drawings depict quipucamayocs holding and presenting their khipus to Inca rulers and even to Spanish officials, providing visual evidence of how integral these devices were to every level of society. These chronicles, written by people who witnessed the transition, offer precious clues. They describe khipus being used to record laws, historical narratives, and even the lyrics to songs, hinting at a narrative capacity that we are still struggling to fully understand. While the Spanish tried to erase the khipu, these surviving threads and texts provide a lifeline to a lost world of knowledge. For centuries, these surviving khipus remained a mystery. We could see the numbers, but what did they mean? What stories were these knots waiting to tell? The quest to decipher the khipu is one of the great intellectual detective stories of our time. Modern researchers, armed with computational tools and collaborative databases, are making incredible breakthroughs. The Khipu database project at Harvard University, for example, has been systematically cataloging the structural and color details of hundreds of khipus, searching for patterns. And in 2017, a major breakthrough occurred. Researcher Manny Medrano, then an undergraduate at Harvard, was examining 6 khipus from the 17th century coastal valley of Santa, Peru. By cross-referencing the data on the khipus with a colonial-era Spanish census document from the same region, he found a match. The khipus appeared to be organizing individuals based on their social status and family groupings listed in the Spanish text. The total counts on the khipu cords corresponded to the census numbers. This was a monumental discovery, a Rosetta Stone moment for khipu studies. It demonstrated that khipus didn't just record numbers, they encoded social information about the people being counted, using features like cord color and attachment styles to represent a social hierarchy. It was a tangible link between the abstract numbers and the living, breathing society they described. So, was the khipu a form of writing? Perhaps we are asking the wrong question. The khipu wasn't trying to be an alphabetic script. It was something different, a unique system perfectly optimized for the specific needs of the Inca state, managing a decimal-based economy built on labor and commodity redistribution. It was a specialized tool, a bureaucratic language that prioritized quantitative data, categorization, and speed. It reminds us that human ingenuity finds many paths and that our modern, text-based world is just one way of storing and sharing knowledge. The khipu is a powerful testament to a different kind of literacy, a tactile, three-dimensional language written in fiber. It's a reminder that there are still so many secrets left to unravel, knotted in the threads of history. Thank you so much for joining me on this journey into the heart of the Inca Empire. If you found this fascinating, please hit that like button and subscribe for more deep dives into history and technology. What other ancient systems of knowledge would you like to see explored? Let me know in the comments below. See you next time.